Okay, so for number 4, you have a geometric sequence, and they want you to find the explicit and recursive rules. Okay, so the a sub 0, that's the first term in the sequence, so this would be 0.1. That's this one right here. And then for the ratio, you put the second number over the first number, or you could go use any two consecutive numbers and put the later number over the previous number. And so this gives you 3. So now we're going to write the explicit, and it's f of n. Now because we're starting with 0, we use the formula, or the explicit formula, for beginning with 0. So that's the first term in the sequence times the ratio is 3 to the n power for n greater than or equal to 0. For the recursive, it's going to be f of 0 equals 0.1, and then f of n equals, oops, that looks ugly, hold on, f of n equals the ratio times the previous term or previous number for all n greater than or equal to 1. Okay, so number 5, we have the numbers are decreasing, so we know that the common ratio is going to be between 0 and 1. So the a sub 0, the first number on the list, is 100. And then to get the common ratio, I'm going to take the second number over the first number. So that's 1 over 10, or 0.1. However you want to write it is fine. Okay. So the explicit formula or rule is going to be f of n equals the initial number, which is 100, times the ratio. So again, you could put it in either as a fraction or a decimal. It doesn't matter. I'll put it in as a decimal to the n for all n greater than or equal to 0. For the recursive, the first number on the list is 100, so that's your f of 0, and then f of n equals the ratio, which is 0.1, times f of n minus 1 for all n greater than or equal to 1. Okay, so remember, 0 is where you start the list starts, right? 0. So then the next number is 1. So that's why you put greater than or equal to 1 right there. So for number 6, a sub 1, that's your first number on the list, is 1000. The ratio, I'll take, just to show you that I can take any two consecutive numbers, so the fourth number, which is 1, over the third number, which is 10. Okay, so that's 0.1. And again, you could keep it as a decimal or keep it as a fraction, it's up to you. Okay, so for the explicit formula, it's going to be f of n equals the first number times the ratio. Now because this started with 1, the n starts with 1, I'm going to put n minus 1 for all n greater than or equal to 1. For the recursive, f of 1 is 1000, and f of n is going to be the ratio times the previous number for all n greater than or equal to. Since the first number starts at 1, then the second number would be 2. Okay, so number 7 starts with 1, n equals 1. The first number, a sub 1, is 10 to the 50th power. For the common ratio, I'm going to take the second number over the first number. And so remember, when the base is the same and you're dividing, you subtract the exponents. So this is 10 to the 47 minus 50. So that's 10 to the negative 3. Okay, and that's your common ratio. Oops, doesn't look right. Negative 3. So now f of n equals the first number times the ratio. Because the sequence begins with n equals 1, the power here is n minus 1 for all n greater than or equal to 1. And then for the recursive, we're going to write f of 1 is 10 to the 50, and then f of n is the ratio, so negative, times, well, I don't need the parentheses actually, just the dot, the previous number for all n greater than or equal to 2. Okay, you may be needing a calculator for some of these problems, 8 to 11. So let's see, number 8, and when n is 0, so you just plug it in, replace it with the n up here, and the n right here. So f of 0 is 1/2 times 4 to the 0. Well, 4 to the 0 is 1. So 1 times 1/2 is 1/2. Now, if you know how to read the equation, then you don't really, you don't have to be plugging in the numbers each time. You know that the ratio is 4. The common ratio is 4, and this is the initial number, right? So the common ratio is 4, so that means I'm going to multiply this by 4. So it's going to be 4 times 1/2 is 2. And now I'm going to multiply this 2 by 4. 2 times 4 is 8. 8 times 4 is 32. And 32 times 4 is 128. Then they ask you to graph it. So now we plot the points. So 0, 1/2. So that would be about here. 1, 2, right here. 2, 8. And that's as far as I'm going to go, just because 32 and 128 are too big. But you could see the exponential shape of the graph. It's not in a line, it's an exponential graph like this. So on number 9, we know that the initial value is 1/2, 0.5, so I'm going to put that here on the table. And I know that the common ratio is 2. So that means I'm going to multiply this 1/2 by 2, so that's going to give me 1. 1 times 2, that's going to give me 2. 2 times 4, 2 times 2, that's going to give me 4. And 4 times 2, that's going to give me 8. And so now we're going to graph it. So remember, always label your graphs, so you've got to make sure that you label the horizontal and the vertical axis, and then also the numbers. Okay? So we're ready to graph the points. So 0 goes to 1/2, 1 goes to 1, 2 goes to 2, 3 goes to 4, and 4 goes to 8. Okay? Again, you could see the exponential growth. Okay, so for number 10, the first number in the sequence is 8, because f of 1 is 8. You could see it right here in the recursive formula. So it's 8, and the ratio is 1/2, 0.5. So that means that I'm going to be multiplying each number by half, or dividing it by 2. Okay, so 8 times 1/2 is 4, 4 times 1/2 is 2, 2 times 1/2 is 1, and 1 times 1/2 is 0.5. Okay, and I forgot to add the little dot, dot, dot. Okay, so here's the graph on the right side. For 1, I get 8. For 2, I get 4. For 3, I get 2. For 4, I get 1. And for 5, I get 1/2. And that's it. Alright, so for number 11, the first number in the sequence is 1. F of 1 is 1, so I'm going to put 1 there. And then we're going to multiply by 2/3 each time. That's the common ratio. That's the number right here. So 1 times 2/3 is 2/3. 2/3 times 2/3, remember I'll put it here on the side, 2/3 times 2/3 is 4/9. And then 4/9 times 2/3 is going to be 8/27. And then 8/27 times 2/3 is going to be 16/81. Oops, over 81, not 0.81. So 16/81. Okay, so it's probably better to convert them to decimals just because you have a better sense of, let me erase this 1/3 and 2/3, better sense of where they go on the number line. So 2/3 would be 0.67. Oops, erased. 4/9 is 0.44. 8/27, 0.30, and 16 divided by 81 is 0.20, because I'm just keeping two decimal places. Okay, and on, let me erase the y-axis. So on the y-axis, I numbered every line as 0.2. So you could see here 0.2, 0.4, 0.6, 0.8, and then 1. Okay? And so now for 1, it's 1. For 2, it's 2/3 of 0.67, so it's about 0.7, so it's going to be somewhere around here. And then for 3, it's 0.44, so it's going to be about here. For 4, it's going to be 0.3, about here. And for 5, it's going to be 0.2, about here. Okay? So you could see the exponential decrease.